I'm CK. Tonight we're gonna start building a Music Thing Spring Reverb Mark II from Thing over in the UK. This is a spring reverb that can work either with a digital spring module, or it can work with a real spring reverb tank, and I happen to have a spare Mojo Tone reverb tank right here, even though I think they actually subcontract these from ModWorks, but they're branded as Mojo Tone. So we'll put the unit together and see how it drives a real physical spring tank. I might even compare it with my ModWorks tube-driven reverb unit, but I don't know whether I'm going to drag that out from my main studio out into the garage or not. So we'll see. Hope you enjoy it. So let's see what's in the bag. Music Thing Modular Spring Reverb Mark II. There's a QR code for build guide. Looks like we've got some transistors and probably an IC in here. Here's the front panel. Let's see what she's got. Feedback, tilt, CV, feedback, crossfade, input signal, full wet signal or the wet signal, and I guess this is a dry signal. I'm not sure. We'll take a look again at the guide. And it's got off, on, and on with a backwards N. So that's that. Here's the circuit board. It's actually two boards. We'll break this in half. Interestingly, it's got gold tone solder pads, not silver. Spring Reverb 2, designed by Tom Whitwell, Henry Hill in London, August 2017. So it's a relatively recent, it's 2021 as I'm recording this, so it's a relatively recent design. We've got a little jumper here. It says close if brick not installed, so I assume that's the digital reverb tank, which we're not going to use because as I showed you, I've got a spare reverb tank lying around. Red and white, which are the input and output to the tank. That'll probably be RCA jacks. And yeah, we've got, the board is labeled pretty well, the values for all the resistors and potentiometers and so on. The only thing I don't really, let me see if I bring this closer. This is not working. These resistor values are really close together. It's hard to tell which ones are which, but I'm nitpicking now. Board looks pretty good. Oh my, okay. Gonna be, this is one of those kits. I'm not a big fan of these. That's got a little plastic bag for each component type or subcomponent type. That's just too much plastic. I would prefer less plastic. And here's a bunch of the mechanical stuff. Here's our RCA jacks that'll go to and from the tank. Here's the big knob, which we'll put up here and go reverb. See if we can get some good surfy tones out of this thing. I'm going to pour the rest of the mechanical stuff in this bin and we'll take a look at it. Eurorack power cord, some jumpers and pins to connect the two boards. Switch, that's the on-off switch. What's this? An optocoupler? Maybe. Actually, I'm not sure what this is. It does say LED plus on it. That's why I was thinking it might be an optocoupler, but that's an odd shape for it. We'll see what that is when we look at the build guide. Nothing else too extraordinary here. A couple more pin headers to stack the boards together with. Okay, I'm going to go over to my iPad. Reverb build guide. Okay, tools required, how to solder, identifying resistors, yeah. Okay, good. A lot of pictures with step-by-step of putting all the components in. So, I mean, even more steps than I would necessarily. But you can't have too many steps. I'm still looking for that. And there's the trimmers. Vactrol, that's a Vactrol. VTL5C3. Okay, we're going to start by separating the two PCBs. I'm getting rid of the shim spacer piece in the middle. Fortunately, these are, I think these are marked. Front board and back board. So you shouldn't get confused when you're putting this together. So we're going to do the, I'm going to kind of fast forward through all the resistors. So I'll mount all the resistors because there's quite a few of them. And then I'll do that in fast motion and then come back when we switch over to another component. So welcome to fast motion and background music. I'm going to be soldering away listening to WQXR, which is playing right now. WQXR, classical radio out of New York City. I use their app. And they're actually playing a Fibbage piece at Twilight, Opus 39. I'm not sure I've even heard this before, so that'll be fun. So enjoy the fast motion. Now we're going to dive into the static sensitive bag. And besides the ICs, there is a little voltage regulator. One thing I didn't point out that I found interesting with this kit is right here there are two, besides the diodes for polarity protection, this kit has two fuses, one for both energy rails, and that's pretty good. I don't see fuses a lot in eurorack stuff, so that's interesting to see. But next is the voltage regulator. They did display it. Sometimes they lay them inline, sometimes they display them as a tripod. This is a tripod one, which I guess some people think is easier to solder without bridging, but I don't. Once you get the hang of it, the inline ones are just as easy to not bridge as, or I should say, equally as difficult to not bridge as the tripod shaped ones. Oh, the other thing that is interesting on this board is instead of using a socket, they use bare pins for the power connector, which is not a big deal, except it just means you have to be very aware of where the red stripe on the ribbon cable is, since there's no key protection from a socket to make sure that tab is going in the right place. Saves a couple of bucks, probably, a couple of cents probably, but now the Vactrol. So you don't see these a lot. It's got an LED on one side and a photoresistor on the other side, so the amount of energy applied to the LED varies the voltage, varies the resistance on this side. Now on the opposite, the complementary piece, the optocoupler, which uses an LED and controls, which controls a light-sensitive transistor, which controls resistance, which controls current flow, is much more commonly seen. A variable resistance versus light is not seen out all that often, and it also, part of the reason why is it's not really the most stable, for lack of a better term, component. Its reactive curve is not necessarily smooth, and it's, let's just say it's idiosyncratic. It's not something that you're going to get a linear response from in all situations, so people don't tend to use them. I think, I rarely see them in anything. You'll see them in probably analog synths more than anything else. And these leads, it's so big. It's so clunky. And I gotta get it. It doesn't really fit the pad, the silkscreen pad. So you gotta convince it to go down, because we're going to be mating two boards and you don't want the Vactrol sticking up and preventing the front panel from going down close enough. And I think it'll be fine. Let me put a pin header on here just to be sure, because if it clears the pin header, then it'll clear. Yeah, it'll clear that just fine. So you want the Vactrol, which is a fat component, to be as flat on the board as you can get it. Without pulling the leads out, because it is, if you notice, it's just potted on this side, so it's possible, if you're too rough with it, that you could pull the photoresistor out of the case, and then you'd be very sad, because number one, you couldn't finish the board today, but number two, then you got to go find somebody who'll sell you a Vactrol, because I think there's only one company that makes them, and not every supplier carries them. Next are our pin headers. So there's one pin header here. I'm not real sure what this one's for. What is that for? I'm not sure, so I'm not going to speculate. So let's tack one leg in place. Now we'll look at it and make sure it's perpendicular, and heat that one leg up a little bit just to make sure. Yep. Now we'll get the other legs soldered down. Now my least favorite thing, I have to cut apart the male pin headers into an 8 and a 6 pin section, and I always hate doing this because for some reason or other I've never bought a supply of spares of these, so if I mess it up, I mess it up, and I have to stop. Let's see, 1, 2, 3, 4, 5, 6. Come in here, clip it. Here we go. Oops, wrong side. So the 6 pin goes here. And same thing, tack one leg down, pick it up, look at it. It's both, no, it's not quite perpendicular, and I just dropped my solder. It's not quite perpendicular, so again, reheat the solder on that leg and flatten it out, and there we go. Oops, that's not right. There we go. I did it again. I kept pulling away too soon because, quite frankly, because I was burning my finger heating that pin and having my thumb touching it because I'm an idiot. So that it lifted up off the PCB. But now everything's dandy. Yeah, that's a note to self. Buy some spare pin header rails so you don't stress over this every time you have to clip them. Let's see what's next. Okay, now we've got expansion headers. Where are they? Oh, there they are. It's these little guys. I believe this is where the digital brick, the digital reverb tank you could buy, a little guy, goes on this, and we're not going to be using it, but we're going to install the headers anyway, because who knows, I may get one of those bricks someday just to do a comparison between the digital and the physical spring reverb, since I don't currently have any units that do both except this thing that I'm putting together right now. So it'd be a nice real comparison. We'll plan for that sometime in the next little while, because that would be interesting. I've never done a comparison completely with the same hardware. Obviously I've tried electronic reverbs, spring reverbs versus physical spring reverbs on different units, but not on the same unit. So that would be kind of fun. And I think it's just a matter of setting jumpers on this board to decide which one the signal is going out to and coming back from. So now we're going to put the RCA cable connectors on. These are what the spring reverb tank will connect to. It looks like it might be polarized or something, but it's not. Doesn't matter. You can't put these on wrong. Ouch. And you'll see these are marked red and white. And hold on one second. Most physical reverb tanks use a convention of the out being red and the in being white. So this makes it dead simple to set this up correctly so you don't mess up. As always, these are sockets, so don't skimp on the solder. That's the mechanical connection that's going to protect this from coming loose as you connect and disconnect the tank over the years. So use a bunch of solder. I think I only have one RCA cable made up. I'll have to make some up. I think you can get an expander for this unit that allows you to put the tank connections on the front, and if I were gigging or taking this more than one place into another studio or something, I might think about that. But for something that's just going to sit in my studio or out here in the shop, I don't need that. Okay, now we're going to do the rest of the trimmer pots, which are going to go on this board. We're going to do the trimmer pots and put the jacks on and the LED, getting ready to mate the front panel on top. And as usual, we don't solder anything until we get the panel mounted. So we've got one 50K and one 10K trimmer. These are the tilt and CV controls that'll go through there. So make sure we get them in the right place. B103, that's the 10K. And straighten up the pins a little bit. When I get to panel mount components, I put them on in order of how much effort it takes to push them onto the board. The ones that take the most effort to push on the board I do first, because then I don't displace more delicate things after the fact. Come on. Come on. There we go. And this leg's not going in. There we go. That's seated and flush. Just put the board on it just to. Yep. Now that both green pots are both 50Ks, feedback level and mix. I'm trying to see which component is driving the height. The thing I always care the most about is which component is driving the distance between the PCB and the control panel. And it looks like it's these green pots. Green pots and the jacks are on the same level. Okay, now we're going to put the front panel on. Hold it while I tack solder a couple of things. I'm going to tack solder one of the legs of this pot up here. Oops, but I don't want it to get away from me. Just a little bit, just enough to hold it in place. Then go down to this end and tack solder one of the jack legs. I'll do this middle one. And with those two tacked, I'm going to put the panel nuts for those two on loosely. Now we'll take the front panel back off again momentarily, or for a while. Make sure everything twists. Check the jacks. Yep. Yep, let me trim off these leads off the LED or else nothing's going to fit. Now we put the chips in the backboard, and this is what I don't particularly care for on these round hole IC sockets. It's a little bit tougher, for me at least, to get the pins in there, different than the rectangular holes on the standard socket. And now we're going to mate them. Always the more challenging bit. Make sure all the pin headers line up, and they do. That went together really smoothly. There's still a little flex up here. I might have put a hex. Yeah, see, I would have put a hex spacer here too, because while this is the sockets I'm not worried about, but putting the RCA jacks in and out, you can see the circuit board flexes, so I'd recommend adding a spacer like right here. In fact, I may put something in there myself just to prevent that flex. But I'm not going to do that right now. I'll do that after I get it all assembled and tested once. Because it doesn't make sense to do it if it isn't working. Okay, so we've got a shunt right here. If you put it here, if you're using the tank, the digital brick, you put it here if you're using a real tank. And we're using a real tank, so we'll put it there. I'm going to go ahead and put the panel on. Yep, I have my switch in there. This is, of course, our favorite part, mounting panel nuts without scratching the panel. And there we go. That's the unit all put together. And next we'll mount it in the rack, hook up the reverb tank, and see how this guy sounds. Okay, so we're ready to go. We're going to be feeding the signal to my 15-watt amplifier that I built about a year ago. And then module-wise, we're going to be going from an 8X Systems oscillator into a Patching Panda Punch VCA, and we've got an ADSR from Befaco, the Befaco Out module, a dual sequencer from Division 6, and finally a Frequency Central power supply. Now, one thing you may notice is I've got the reverb tank off on the end of a board because it can pick up vibrations very easily. The other thing to be aware of is you need to be careful with your cable routing to not get interference. So I'm going to do two things. I'm going to do a dry signal and then a wet signal. I'm not going to mess with anything else with this right now, but you'll get to hear what it sounds like wet and dry. So let me put the mic in front of the amp. And we'll fire it off in dry. Now I'm going to feed it into the wet side. And it started to pick up some feedback in the end there, so I turned it down. So as you can hear, it does really reverberate. As I mentioned I was planning to do, I went to Thonk's website and bought the digital reverb brick. This is a medium. They have a short, medium, and long version. I only bought one this time. I bought the medium. As you can see, it plugs in to the back of the board. It's a very compact unit. It's no wider than the front panel on the unit itself, so it's not going to interfere with other things in your rack. So that's the way it looks from the back. Let me reconfigure so we can hear how it sounds compared to the reverb tank. Now we're set up. No feedback, no reverb. I'm going to turn the sequencer on for a steady pattern. Now I'm going to turn the wetness up. So it reverberates really well. We take it down to 0 again on both feedback and on verb, and go to the bottom position. And now the middle position. So as you can hear, it's a very credible. So as you can hear, it's a very credible reverb with interesting feedback options. With the digital brick, it works really well. So this is a nice little spacey reverb unit. I think I'm going to buy the long reverb brick also, give that a try, because that may give me the space and expansion that's even better than this, even though again this is really good. So overall, a very nice little unit. Hope you enjoyed it. That's the idea. It's a good little feeder to the reverb tank and sounds good. Hope you enjoyed this video.